YouTube channel. Today we will learn about elementary matrix, and basically I'll try to show how we can do the Gaussian elimination using the elementary matrix. So if you're following my channel, then probably you know that Gaussian elimination is a process by which we can solve the system of equations, and our main objective was basically creating a upper triangular matrix so that we can make the equation very simple, and then from the computation point of view it will be easy for computer to solve these equations. Now elementary matrix, by definition, it is kind of a identity matrix. Only thing, one of its element is non-zero. So just for example, before we actually start the class, so example of elementary matrix is something like this: 1 0 0, let's consider 2 1 0 0 0 1. So this is actually identity matrix, but one of the element of this identity matrix is non-zero. So that's basically the elementary matrix. Okay, so now let's see how we can do the Gaussian elimination steps using the elementary matrix. So let's consider we have a matrix of this form. So -3 to 1, 6 -6, 7, probably 3 -4, 4. So from the Gaussian elimination point of view, the first step is basically we'll multiply this by 2 and then just add. So that will give me the next matrix. So that's mean my -3 to -1 will be as it is, but this one will create 0, and 2 into 2 4, -6, so -2, 5, and then 3 -4 -4. Okay, now what I'm trying to say here, that after this first step I want to write this as if the M1, or let's make it elementary matrix. So let's slightly write this, it's E1 and A, elementary matrix, and the original matrix will give me this result. So what I'm trying to say, like using this Gaussian elimination steps, we are forming this one. Okay, but what now my objective is, can I write this matrix just by this? So basically multiplying an elementary matrix with A, can I write this? And if we see, if I get an elementary matrix like this, which is, so first line there is no change, so that's mean I can keep it 1 0 0, and this line there is no change, I know, so I can keep it 0 0 1. But this line we see there is a change actually happened here, that's mean we have to do some adjustment. So now this will be 1 because we know that's the identity matrix. So one of this two elements, probably we have to adjust. Okay, so let's consider how this can be 0. This can be 0 if I make this value as 2. Why 2? Because if you now check this multiplication, this one, 6 into 1 6, minus 12 14, yes, so this one, and if you multiply this a, this will give you this element as 0. Okay, so just to prove that okay, this elementary matrix is the right choice, what I did, I just did this calculation instead of wasting the time. So now let me show you exactly. So this is my first elementary matrix, and if you multiply this elementary matrix, so this is elementary matrix E1, and if you multiply this with this, you will get this step, and that's why I just wrote it here. So I think it's very easy. When you are multiplying with elementary matrix, you will get the same row, this one will be same row, so I'm not showing this too, but just understand this part. So when you are calculating this, what you are doing, you are basically multiplying 2 into minus 3, which is minus 6, 1 to 6, which is 6, and then 0 to 3, which is 0, so you ultimately you will get 0. And same way, if you check 2 to 2, which is 4, minus 1 to 6, which is minus 6, and then 0 to minus 4 is 0, so ultimately it will be minus 2. So you're kind of understanding how we are coming up with this elementary matrix actually. Okay, so now we got the E1, and our first matrix is looking like this. Okay, up to this I think it's very clear. Okay, now what is our next step? Like if you do the Gaussian elimination, still we are actually on this pivot, and our next objective is basically make this one is 0, right? That's the steps we follow for the Gaussian elimination. So we can simply multiply this with 1, and then actually add it, right? So yep, so what will happen, so our next step, so from the Gaussian elimination point of view, this is my step 1, and Gaussian elimination step 2 will create a matrix like this. Again, my first row there will be no change, my second row also there is no change, but the third row, when I'll do the add, what will happen, this will be 0 and this will be minus 2, because what I'm just doing, I'm just multiplying this by 1 and then adding it, right? And if you add this, so 4 minus 3, so this will be 3. So now this one again, how we can write it, we can write it that we have another elementary matrix and we have 1 and we have, so this one we want to write like this. So that's mean this is our first elementary matrix, and now the after second steps we think, okay, can we write this entire piece as a another elementary matrix? And we can do that. How we can do that? If you think properly, so absolutely there is no change on the first, so you're very sure there will be no change. There is no change on the second one, because look, the second one is also no change, so there is no change. But third one is have a change, and if we have to make it 0, so you have to just multiply it by, because ultimately this result, which is my, So this combination of result is this step. So you're trying to now multiply with this and get it back to this one. So how will get it 3 if you have here as 1 and 0, and this one will be 1. Okay, again this is elementary matrix because this is not identity matrix. We have one non-zero element, so this is my third one, second elementary matrix actually. And for this second elementary matrix, how we find this one? Again, very simple. If you multiply this elementary matrix just to prove that, okay, minus 3, sorry, it's not comma actually, remember this is not a comma, minus 1, 0, minus 2, 5, 3, minus 4, 4. If you do that, you'll see simply when you will do this last line actually. So how you do the normal multiplications, you have to be very smart on the multiplication. This one will get multiplied with this, right? So let's see, 1 minus 1 is minus 1, 0 plus 5 is 0, and 1 plus 4 is 4. So what we are coming back? We are coming back 3, which is nothing but this one. Okay, so that's the piece is very important. So we are up to this, but still we are not up to, we are not created the upper triangular matrix, right? So that's mean we have to go one more step, and one more step is very simple. We can just simply multiply this second row by minus 1 and add this second row by minus 1 and add it, we will get it. Okay, so let me write from here to here so that I can keep it in the same screen. So if you do that, finally your matrix will look like minus 3, 2, minus 1, 0, minus 2, 5, 0, 0, and this is minus 2. Okay, this is my final form, and this is upper triangular form. But now I want to write this again, E3, E2, E1, elementary matrix multiply by A. So we know the result of this thing. We know the result of this thing. The result of this thing is basically, what is this one? The result is, this result is nothing but this one. Okay, minus 3 to this one. So we need another elementary matrix which will multiply this, and that will give me back again the original matrix, this matrix actually. Okay, so which will give me this matrix actually, this result actually. So my E3, let me put the black color. So my E3 will be, again let's think about first row, there is absolutely no change, so it will be 1 0 0. Second row there is no change, so now the third row we have to make an adjustment. How we can do it? 0 0 minus 1. So if you do it minus 1 and 1, because we multiplied by minus, so that's why it is minus 1. Okay, so these are the three elementary matrix. So now finally what we can say, that M2, not M2, give me 1 minute. Okay, so finally what we can see, that E3, elementary matrix 3, elementary matrix 2, elementary matrix 1 multiply by E is giving me the U, which is the Gaussian elimination form. Okay, so this is very important to understand, very important to understand. So first let me use some different color probably. Okay, So first E1 is this one, second E2 is this one, this one, and this one. Okay, and finally we got this one. Hopefully it's clear to everyone. Okay, so I think it's clear, the complete elementary matrix. If it is not clear, again you can email me, we can discuss more and we can learn together and grow together. Have a nice day, have a blessed day. See you in the next video. Thank you so much.